In this new unit, you're going to be using your calculator because we are going to be calculating side lengths and angle measures of non-right triangles, finding area of non-right triangles as well. And so before this, you knew how to solve for a side or an angle of a right triangle. So like if this was 36 degrees and you were looking for this side and you knew this side was 17, what would you use to solve for x?
Sine.
You will use sine, and you would say sine of
36
equals,
x over 17.
that's right, opposite over hypotenuse. Then you would multiply both sides by 17, and then you would type 17 times sine of 36 into your calculator to get your answer, unless you have one of those other type of calculators where you had to go backwards and do 36 sine times 17, okay? If I was looking for an angle of a right triangle, like if I wanted to know what this angle was and I knew this one was 4 and this one was 3, I would use what to find theta?
Tangent.
It was tangent, because tangent is what over what?
Opposite over adjacent.
Exactly. 4 was your opposite side, 3 was your adjacent. And then to find the angle, what did you have to use in your calculator to get the angle?
The tangent of like the -1.
Anybody know what that's called? When you see that -1 and an exponent? The inverse. It was the inverse. And you would do on the more fancy calculators, or maybe even more some of the basic ones, second tangent, and then it pops up the -1 and the exponent. You just do 4/3 and you would get your angle. Those SOHCAHTOA is only used for right triangles. For non-right triangles, you either use the law of sines or the law of cosines. There is a law of tangents, but that's for other classes, not this one. This is the law of sines, okay? It is the ratio comparing your sides to your respective angles. So A over the sine of angle A equals B over the sine of angle B equals C over the sine of angle C. And just to make sure that we know our differences, capital letters represent our angles, lowercase letters represent our sides, which means is that side A is across or opposite of angle A. Side B is across from angle B, and side C is across from angle C. So lowercase letters represent your side lengths, capital letters represent your angles. Now, when it comes to using the sine rule, you're not going to use all 3 fractions to solve for a side length or angle measure. You're going to determine based off of the information you're given whether or not you're going to use A and B, B and C, or A and C. Okay, so you only use 2 parts of this formula. Also, it might not always be A, B, and C. It could be D, E, F, D, O, G, C, A, T, X, Y, Z. Okay, but no matter what, the side length goes over the respective angle. Questions? Now, you don't always use law of sines for every non-right triangle. There's certain situations when you would use the law of sines. That happens with AAS and SSA. What do they stand for? Right here. If you think back to like geometry, angles and sides, when you have 2 angles and one side are known. So what does that look like? I know this angle is 30, and I know this angle is 80, and I know that this side is 7. I would use the law of sines to find another side length or angle. The other situation is side-side angle. It is side-side angle, not angle, side-side. Okay? It is side-side angle. And that stands for 2 sides and the angle opposite of one of them are known. So if I know this side and this one, I know one of the angles that are opposite of one of the sides given. So let's say this is 15 degrees. This will be an example of side-side angle. Okay. Unfortunately, when you have side-side angle, there is such a thing called the ambiguous case. That means is that this could potentially, with this information, create not one triangle, but two triangles. Ambiguous case only happens in these particular situations and only when the following information happens. You may have two triangles in the situation of a side-side angle case. This is because when you take the sine of an angle, remember, sine is positive in the first quadrant and the second quadrant. When you have an angle in the second quadrant, you have created an obtuse triangle. The calculator, when you are doing your calculations, doesn't find the obtuse angle, it only finds the acute angle. Again, this only happens when one side is smaller than the other, and more specifically, when you're given those two sides, the angle opposite of the smaller side is also given and acute. I'll say that again. There's a possibility that you may have two triangles. This happens in a side-side angle situation when the angle given to you is acute and the side opposite of it is smaller than the other given side. What you see on the screen is how that's possible. You have one triangle where you know this angle, you know this side length, and you know this side length. But realizes that side A could also be moved and still have the same length that it had here with the same angle and the same side. The only difference is that these two angles here and here are going to be different, and these two angles up here and up here are going to be different. These lengths also, sorry, I drew that one wrong. This length and this length will be different. This will not happen every time, but you do need to check to see if you have an ambiguous case. There's also a possibility of having no triangles. If you have an error message, okay, don't think you did something wrong. Of course, check your work. But if you get another error message, that means there's actually no triangle that can be created with those respective measurements. Let's look at an example. We'll look at a couple too. Solid triangle ABC, where side C is 12. Capital C is 55 degrees, and angle A is 45 degrees. I strongly suggest that you draw a picture. To be honest, it makes things just a little bit easier to see. Doesn't matter where you label your A, B, and C. Okay, figure out. Angle A is 45, C is 55, and side C is 12. Remember, the respective sides across from its angle. When it says to solve the triangle, that means to find all angles and all sides. Right now, I only have two angles and one side, so that means I have to find two sides and an angle. Is this a side-side angle situation? No. It's an angle side. So I do not have to worry about the ambiguous case. Okay? Simon, you got a question?
No.
All right. I need to solve the triangle. That means I need to find the missing angles and sides. Well, one thing's for sure, I can find angle B pretty easily. How many degrees are in a triangle? 180. So to find angle B, I would subtract 45 degrees and 55 degrees from 180 to find angle B. Now I'm trusting you guys to do this and give me correct answers. So I am going to ask for confirmation. So make sure everyone is doing this. 80 degrees. So angle B is 80 degrees.
Should we put our calculator back in degrees?
Oh, yes, your calculator should definitely be in degree mode. Your calculator should definitely be in degree mode. Otherwise, you're going to answer some crazy answers. So now I need to find side A and side B. Doesn't matter which one I find first because I need to find both of them. So if I wanted to find side A, I would use the law of sines to do this, okay? Since I'm looking for side A, that's my variable, it's going to be divided by the sine of angle A, which is 45 degrees. I need to set it equal to one of the two other parts in the formula for the law of sines. You want to use the other fraction that you know the most information for, which is C. Because I know side C is 12, and I know that angle C is 55. So I use the A and the C in the formula so I can find A. From here, it takes you back to algebra 1, you cross multiply. I am going to show out all my steps because I don't want to lose anybody at any point. If you already know how to solve these types of problems, then by all means, go ahead. This is how I would do it. Cross multiply, and then divide both sides by the sine of 55. So what I type into my calculator is the following. Do your best to not round in between. So if your calculator maybe can't do what like the graphing calculators can do, don't round the numerator and round the denominator and then divide two rounded numbers. You're going to be very far away from the answer. Okay?
Miss Anderson,
Yes.
how did you get A sine 55 over sine 55 and then only sine 45 and the numerator on the one on the right?
I actually have 12 sine 45 on the right. But the sine of 55 on the denominator came after I started to solve for side A. So when I cross multiplied, this is what I had. I had A times the sine of 55 equals 12 times the sine of 45. So then when I started solving for A, I divided. Oops.
Okay, thank you.
No problem. So when I type this in, I get my value of A. What did you guys get for your answer?
Or 4.
Is it 4 or 5? It's 4. All right, 10.4. And if there were units, of course you would put your units, but there are no units here. So it is 10.4. How should you round? I'm always going to say 3 significant figures. Always. Okay. All right, let's do B. I need side B, which means I need to put that over the sine of angle B, which we found to be 80. I'm going to set that equal to what? I could do either A or C, but C would be the better one because remember, we rounded A. And remember, if we round or we use a rounded answer, we're going to be further away from the actual answer. So I'll always use what's given. So that's gonna be 12 over the sine of 55. I'm gonna cross multiply again. It's gonna be b times the sine of 55 equals 12 times the sine of 80. Remember, in cross multiplication, you set them equal to each other. Then I'll divide both sides by the sine of 55 to isolate my variable. And I type into my calculator 12 sine 80 divided by the sine of 55. And again, I'm hoping everybody does this so we can make sure you're capable of getting the correct answers. 14.4. So then there are my two, there's my triangle. I have solved for my triangle. I found my missing angle, which was 80 degrees, and my two side lengths, which were A and B. A few things on this particular problem. Okay, so first off, you were asked to find side C. You were asked to find side C. And so you have to take a look and kind of see what else that you have, okay? Clearly, we can see that 105 and 35 represent what? Angles. 7 represents what? A side. Which side? It represents side B, okay? So based off of this, you already know side B and angle B, correct? So you're going to use that part of the formula from the law of sines. And since you're looking for side C and you know angle C, that's the other part of the formula that you're going to use in the law of sines and cosines. Now on this paper that you're looking at, you probably see this. That too is also the law of sines. It works either way, whether you put the side lengths on top or if you put the side lengths on the bottom. It works both ways, okay? It's just whichever way you choose, you make sure you keep it consistent. So if the side lengths are going to be on top, they're on top for both parts of the fraction. They're going to be on the bottom, they're going to be on the bottom for both. Don't mix, because that's when things go wrong. So we plug in. That's going to be 7 over the sine of 35 equals C over the sine of 105. So this is how we should have set up this problem here. That's how we should have set up this problem here. Cross multiplied and divide, you should have ended up with C equaling 7 times the sine of 105 divided by the sine of 35, which is what? 11.8. So if you didn't get 11.8, look back and see if you set it up the same way. Again, to review 3 significant figures, this was your decimal before we rounded. You start with your first non-zero number, which is here, and you count to 3. You look at this number to see if you round up or down, and that's why we got 11.8. Questions? Let's go back to the notes. Let's take a look at this one. Let's solve the triangle ABC whose side A is equal to 10, B is equal to 14, and A is equal to 39. Let's draw it out. Angle A is 39 degrees. Side B is 14. Remember, the side is opposite of its angle. And then side A is 10. Is this an angle side situation or a side angle situation?
Side angle.
So side angle means we could potentially have 2 triangles. Take a look at is your angle acute?
Yes.
It is. Is the side opposite of that angle smaller than the other side?
Yes.
So now it's even a stronger possibility that it's going to have 2 triangles. So I'll walk you through it. If at any point in time something doesn't make sense, stop me. I solve it how I normally would. What would be the easiest piece of information to find? Based off of what you have. Angle B. Because I know side B, I don't know angle B, and I know all my information for side A. I know nothing for C yet. So I'm gonna find angle B. So I start off that way. Using A and B in the formula, I'm gonna do 10 over the sine of 39 equals 14 over the sine of angle B. Gonna cross multiply. I'm gonna divide both sides by 10. Of course, there's gonna be some decimal. And then to find angle B, I'm gonna have to do the what? To get B by itself, how do I get rid of that sign? I have to do the sine inverse of that entire fraction. That's how I get rid of sine B, or that's how I get rid of the sine. So in my calculator, I type sine inverse 14 sine 39 over 10. Go ahead and do that in your calculator. Tell me what you get. So B is equal to 61.8 degrees. So in this triangle, angle B is 61.8 degrees. Now at this point, this is where you should check to see if you have two triangles. First off, we already know that we're going to have at least one triangle because we got an actual value for angle B. If there were going to be no triangles, then we would have ended up with an error message here. Like literally our calculator would say something that would not give us an answer. Okay, so we know we have at least one triangle. This is where we check to see if we have two triangles. Change colors here. So I could potentially have two triangles. How could this happen? Well, we'll label this 2, so we know that this is the second triangle. In the second triangle, all of the original information stays the same. All the original information stays the same. This stays 39 degrees, this stays 10, this stays 14. If we have two triangles, this is what we do. We take the answer that we found and we subtract it from 180. We take the answer that we found and subtract it from 180. What is that?
118.2.
118 point what?
2.2.
Okay. This here is angle B in my second triangle, if I have two triangles. I'll know for sure. I'll know for sure if I have two triangles, if when I add these two angles in my second triangle and subtract them from 180, and I get a positive number. I'll say that again. I know that I'll have two triangles if I take those two angles now, that 118.2 and that 39, and subtract it from 180, and I get a positive number. If I do, that's angle C. Do I get a positive number?
Mm-hmm.
What is it?
22.8.
22.8. So because this produced a positive angle, I am gonna have two triangles, which means I'm gonna have two angle Bs, which I already know. One is 61.8, the other one's 118.2. I'm gonna have two angle Cs. I already know the second one. I still gotta find the first one. And I'm gonna have two side Cs. If that angle C was a negative number, then I would only have the one original triangle. So now that I know I have two triangles, I have to find two sets of information. I already know angle B for both triangles. I know angle C from my second triangle. I still need to find it from my first triangle and both sides C's. It's up to you kind of how you tackle this. Since I'm almost done with this second triangle, I'm gonna go ahead and finish it out. To find side C, I'm gonna use the A and the C part of the formula and do 10 over sine 39 equals C over the sine of. Now, let's talk about this. The more you round, the further off you are from your actual answer. Try not to round in between answers, okay? As you can see here, the first line represents that 61.8 number that you guys got. I did not round that number. I just went ahead and subtracted it from 180. I too get 118.2 when it gets rounded. Then I subtract that 118 number and 39 from 180 to get the 22.8 number, which is correct when you round to three significant figures. But because I need to use that angle to find side C, don't use the rounded answer. Use that long decimal that's there. So to solve for C, I cross multiply again. Again, we're going to use that non-rounded answer for that 22.8 number. And so what I'm going to type into my calculator is that non-rounded answer times 10 divided by the sine of 39. So 10 times the sine of that previous answer, non-rounded. And these calculators is actually kind of nice. If you press the second button and then the negative button, just brings down the previous answer. Divided by the sine of 39. It works the same way on the scientific ones too. You guys should get this for your side C. Do you get 6.15? All right, so then we got 6.15 for the side C in triangle 2. Now go back to triangle 1. We still need to find that rest of that information for triangle 1, okay? Can you guys find angle C and side C on triangle 1, please? Did you guys get 79.2 for angle C in the first triangle?
Yes.
Now, the real question is, when you set it up to find side C, did you use the rounded answer or the non-rounded answer?
I used the round.
Non-rounded answer. Make sure you use the non-rounded answer once you try to find angle C. Side C. Remember, the more you round, the further off you're going to be from your answer. Hopefully we used 10 and 39 to find C, side C. Right, too big for problems like this. So I used A and C in the law of sines formula to find side C. I'm using that non-rounded answer to find side C in the first triangle. Did you guys get this? It is 15.6. And that is how we solve an ambiguous case problem. It is, especially on ambiguous cases, it's a lot.
So we should never really just add our angles together unless, like if there's a decimal, we should never add our angles together,
Correct.
only if they're whole numbers.
Correct. So you should have 2 angle B's, 2 angle C's, and 2 side C's. In this particular triangle, you're asked to, well, you're supposed to solve it. But I was just asking to see, is it 1 triangle or 2 triangles? So regardless of whether or not to determine if you have 1 or 2, you're still gonna have to find angle B. So you should have set it up as 4.8 over the sine of 28 equals 6 over the sine of angle B. Remember, anytime you're looking for an angle, you are going to do the inverse. This will be the last day I write out all the steps. Okay, cross multiply, divide by 4.8 and take the inverse. So B is the sine inverse of 6 sine 28 over 4.8. What'd you guys get for angle B in the first triangle? This is where you check to see if you have 2 triangles, okay? You take that answer and subtract it from 180. What did you get when you took that answer and subtracted it from 180?
144.
So 144 could potentially be angle B in your second triangle. It could potentially be angle B in your second triangle. You'll know if you actually have a second triangle is if you take that number and do what with it?
If you add it to angle A.
If I add it to angle A and I do 180 minus that sum, what do you get? A positive number? 8 point something. So that means you would have 2 triangles here. You would have 2 triangles here, where B1 would be 35.9, B2 would be 144, rounded 3 significant figures, and angle C in triangle 2 would be 8 point some numbers in triangle 2, and we would have to find the rest for both triangles. Okay? And that is the law of sines. The only time you have to check to see if you have 2 triangles is if you have a side-side angle situation. If you have angle, side, or side, angle, you don't have to do ambiguous case. You just solve it straight out.